to solve some more complex problems. We're going to find missing lengths of triangles using the fact that the two triangles are similar. Okay, so we have a figure here, and up here we're asked to find all of these lengths: CD, AD, AE, BC, BD, and BC. Notice we have two similar triangles. We have the smaller triangle here. What I like to do is kind of pull them apart a little bit to get started, because sometimes when they're overlapping, it's hard to see the pieces and how they fit together. Okay, so here's the smaller tip, and it has sides 1.6 and 2.5. Okay, and then my bigger triangle, I know that this side is length 8, my AB. I don't know the lengths of my other sides. The first thing they ask us to find is CD, and it's a little strange that they threw it into this problem, because to find CD we can't really use proportions. The reason for that is because our other triangle they gave us, we don't know the lengths of enough sides. We only know one of its sides, and they don't match up properly over here. So what we do instead is, hopefully you remember something called the Pythagorean theorem. That's how we're going to have to start this problem in order to find the length of CD over here. Okay? The Pythagorean theorem, remember, is for right triangles, which we have there. And it says that a squared plus b squared is c squared. A and b are the legs, and c is the hypotenuse, the slanted side. So a can be 1.6, b I'm not sure, c, the hypotenuse, I know is 2.5. I'm going to use this to solve for my missing side. So go ahead and square the 1.6. And the 2.5. Okay, 1.6 squared, remember, is 1.6 times 1.6. We get 2.56. Plus the b squared equals, square the 2.5, so that, again, that means 2.5 times 2.5, or 6.25. And we solve from there. So let's subtract 2.56 from both sides. Okay, when I do that, I end up with b squared equals 3.69. My final step when you have a squared, your final step is to take the square root of both sides. And when I do that, I get about, I'm going to go ahead and round it off, I get about 1.92. Okay, so the length of CD is 1.92. I've answered the first one. Okay, and I'm also going to draw it in on each of my figures so that I can move on. Right, the next one wants to know what's the length of AD going to be. This one we can use our proportions, because notice we have sides we can match up. So these were similar triangles. This side here was length 8. It corresponds to this side down here, 1.6. So I can set up 8 over 1.6 should equal, okay, now let's go with our other triangles. Our large triangle, I don't know AD, the slanted side, but I do know on the small triangle my slanted side is 2.5. They correspond to each other. And we go ahead and solve that. We just did ratios and proportions in our previous lesson, so hopefully remember we cross multiply. So I'm going to take 8 times 2.5, and that's going to equal 1.6 AD. When I do that, I get 20 is equal to 1.6 AD, and I get all ahead and divide both sides by 1.6. And I get 12.5 Okay, so far I filled in 2 of the lengths. I know that the bottom down there was 1.92 on the small triangle. If I can find my marker. And now I know that AD, the length of the long side of our big triangle, is 12.5. Okay, I'm going to take a quick minute and I am going to clear my screen so that we can do more, or clear off the work. And then we'll carry on. Okay, the next thing we were asked to find in this problem was our AE. So let's take a look at where AE is located. Notice it's the shorter, the section here from A down to E. Now we just found AD, that entire side there is 12.5. So this is going to be a little easier. We don't have to use proportions. All we're going to use is fact. We know that the entire side is 12.5, and we know this little portion down here not included in AE is 2.5. So to find AE, all we're going to do is take our 12.5 minus 2.5, and we're going to get 10. So this section right here is 10. Carry on, the next thing we're asked to find is the length of BD. Now BD is the entire base of that bigger triangle, so we're going to have to use, I guess you can use the Pythagorean theorem, or let's go ahead and practice our proportions. Okay, so again, match up 2 sides that we know from our triangles. Again, let's use this left side of the big triangle was length 8, and the left side of the little triangle corresponded to it was 1.6. That should equal our BD, was from the big triangle, that's the part we don't know, over the bottom of the little triangle, which we found at the beginning was 1.92. We go ahead and cross multiply, leave your equal sign in the middle. So on the left we have 1.92 times 8, and on the right we have 1.6 BD. If we take our 1.92 times 8, we get 15.36. Equals 1.6 BD, and we solve from there. So we're going to divide both sides by 1.6. So 15.36 divided by 1.6, and we get 9.6. Okay, so probably a question is not going to ask you to find all of these parts and pieces. You may, however, have a question that asks you to find one of these pieces, and it might take you multiple steps to get there. So I'm just showing you all of the steps. Okay, so we have 9.6 for BD. I'm going to go ahead and fill that in on the picture also. So this entire line here is 9.6. Because sure enough, the last thing they're going to ask me is the length of BC. Okay, and notice BC is just a part of that bottom that I just found. Okay, I know that the end section down here is a length of 1.92. I know the whole thing is 9.6, so I'm just going to take 9.6 minus 1.92. And I get 7.68. Okay, so I did find all those parts. Again, the first one I had to start off with using the Pythagorean theorem that I pulled from last semester, and then a few of them I used proportions, others we just use simple addition and subtraction.